we are using this. We can also say this joint as hydraulic joint. We are using this joint. This joint is provided where our centrifugal pump, you are also calling to this Tulu pump. You are using this in your home application for sucking water from mains to fill your tank. This joint is provided at there. This is our one pipe. This is the half sectional view of our hydraulic pipe joint. Okay, this is our pipe. This is our pipe. At the end of pipe we have a flange. This flange is of oval shape, and one end of flange is made shocket type, and other end is made like spigot type. Okay, so that they can easily fit, and they can easily be and center of both pipe get easily aligned in line. And this is our spigot, this is our spigot end, this is our shocket end, that easily fit. This is our second flange which is fitted at the other pipe, and starting from joint we have a slope on this side and opposite side also 1:10 in the ratio of 1:10. And at the two ends of this oval shape we have holes of diameter 40 mm. Through this 40 mm dia we have to insert two bolt of hexagonal shape, so that they both joint can easily tight, and we can make it leak proof. To make it leak proof we have to also use a at here and here packing, or you can say a gasket we are using to prevent leakage of liquid or fluid. Now this is the purpose of this joint. Now we are given with this our isometric view of this hydraulic pipe joint. This is the orthographic view of our hydraulic joint. This is our front view, and this is our side view of this hydraulic joint. In our front view, this is our one pipe. This is our one pipe, and from here we are given with slope of 1:10 ratio. Okay, then we are going to whatever size we have at here. Suppose at here we have 140 mm diameter. Then we are given with slope 1:10. 1:10 means if we are moving 10 mm on this side, then we got taper of 1 mm. If we are given with distance from here to here, this is 80 mm. Okay, then we get 8 mm taper on this side. Whatever we have diameter at here, we have diameter at here from here to here 140, and if we go for diameter from here to here, we will be 140 plus 8 mm, because slope is 1:10 and distance is 80 mm. So we got taper at here, or you can say diameter at here 146 mm. Okay, then this is straight part, and we are given with the distance from center line of this bolt to center line of this bolt in our side view. Distance from here to here, this is 250 mm. Okay, we have this distance 250 mm, and we have to use M30. M30 stands for metric thread of diameter 38 mm. This is our hexagonal nut, hexagonal bolt, and at this end we have hexagonal nut. To tight the joint and to make it leak proof, two bolts means we are using 1 and 2 number of bolts in this joint, and we are given with distance from here to here. This slope and distance is 80 mm on this side and this side also, and from here to here this thickness of flange is 70 mm we are given, and from here to here after tightening both the joints we got a clearance of 30 mm from here to here, this at this portion, and from here to here 70 mm, and again from here to this our slope and distance is 80 mm, and after this distance from here to here, this is again our circular braked section. This may you can take 10 mm or 20 mm, it's upon you. space available on your drawing sheet, this distance 20 or 30, and also on this distance you can take 20 or 30 mm, whatever you want. But you have to take symmetric. If you have taken 20 mm on this end, you have to also take 20 mm on this side also. Now in the mid of this face, this distance is 30 mm. In the mid of this distance 30 mm, 15 mm, they have drawn an cutting plane line. And this side view is, if we are cutting this joint about this axis line, about this axis, x-axis, or you can say cutting plane line. If I am cutting with knife or cutter along this line, then whatever I can see, that will be drawn at here. In our side view, it is shown at here, x. If I am cutting this part and removing this part, and after this I am watching from this side, whatever visible I have drawn at here. And where cutting takes place, we have make hatching only in that portion. Only we have material at this end, so we have, where there is bolt, we have hatched at this end, and at here thickness of material is present only in this portion. That's why they have hatched only this much thickness of this circular pipe. And again on this side, if they have make cutting, then this nut is also visible. Internal details of nut is also visible. And now if we are given with this distance 70 mm, and after this we go and come down up to here, and this distance is what? This distance is our, from here to here is 70, and after this in our isometric view we are given with 3 diameters from here to here. Inside diameter of this pipe is 50 mm, and after this from here to here this distance is 70 mm. After this distance we are given with slope 1:10 mm. Okay, sorry, 1:10, not mm. And from here to here this distance is 90 mm. So our this distance from here to here, this radius is 90 mm. If we are going on this side also, then this diameter is 180 mm. Okay, we are given within this isometric diagram 90 mm radius. So with respect to this, first of all we have to draw this axis line, and after this we have to make whatever, because this diagram is circular in shape, so we have to make symmetry on upper side and down side also, and we have to draw half sectional front view. That's why we have cut it in only in 1/4 part. 1/4 part of this flange joint is cut, and after this whatever visible we have drawn. And now we have this diameter 180 mm, and after this we go down, this diameter is equal to this diameter, which is 140 mm diameter, and after this we are given with diameter from here to here. This distance is 20 mm from here to here, and this from here to here is, from here to here this gap is 6 mm, and this thickness of this black part is also 6 mm, which is gasket. Okay, and the thickness of this part from here to here is 8 mm, and from here to here this thickness, this from here to here this is 20 mm. This distance is given from here to here 20 mm. Okay, and from here to here this is 30 mm given on top side, and at here it is given from here to here this is 12 mm, and here to here this is 6 mm and 12 mm on this side also. So now we are going to draw this diagram roughly on board. To draw this hydraulic flange for hydraulic pipe, first of all we have to draw the center line. Okay, after drawing the center line we are given with the diameter. Inside diameter of this pipe is 100 mm. So half of 100, 50 mm, At a distance of 50 mm, we have to draw a light line, because inside diameter gets joined with inside diameter on the other side. It has two ends now. One is, this is our socket end and this end is our spigot end. Okay, because this have at here a cavity, in which cavity the spigot end which get fixed, and it gets easily aligned and diameter to diameter. This is the inside diameter, because we are using half sectional front view, so we are able to see the half diameter, this diameter easily, and on the other side we have to draw hidden lines. Hidden line we will draw in the end, because after drawing completely, this is visible, whatever visible, first we are going to draw that part only. Now this inside diameter is visible, and after this is 140 mm. Diameter of outer diameter of pipe is 140 mm. At a distance of 140 mm, half of 140, 70 mm. In initial distance, it is straight pipe. Okay, this length we will take, let us take this length equal to 20 mm, and after this 20 mm we are given with this length is 80 mm and with slope 1:10. So at here diameter is 140, and on this side at a length of 80 mm, from here at a length of 80 mm, suppose from here to here this length is 80 mm. At this length we have taper 1:10 mm, so we got a taper of 8 mm. 140 plus 8, 140, 148. Half of 148 on upper side and half of 148 on lower side, on this side of center line. This is 140 diameter. After this we have length 148 at here, then we will join this with this, we get a taper on this side. Okay, and we are also given with the, this is taper distance and radius at fillet at here. Now to provide this fillet we can use again the circle master or French curve, so that it get easily sharp. Radius from here to here, this distance is 80 mm. Okay, after this distance we are given with diameter, outer diameter from here to here. This diameter is what? Visible in side view. From center of this bolt to center of this bolt, this distance is 250 mm and 50 mm radius on lower side and 50 mm radius on upper side. So 50 plus 50, 100, 100 plus 250, 350 mm. So half of 350 mm on this side, 175 mm on this side, and 175 mm on this side. And this length is 70 mm. It is given at here. This length is 70 mm. And after this length, leaving a gap of 30 mm, this distance. Then again, leaving gap from here 30 mm, then again 70 mm. We have flange on other side, other end. or you can say flange on spigot end. And then from here we have this diameter from here to here. This diameter is 180 mm. In our isometric view, we are given with 3 diameters. In this isometric view, we are given with 3 diameters, 50, 70, 90. 90 mm diameter is this, which is visible. From here, now let us draw a line in downside up to where we have diameter of 90 plus 90, 180. So half of 180, 90 mm on this side and 90 mm on this side. This is our diameter of 180 mm. And we are also given this center. From this center to this center distance is 250. So half of 250, 125 mm on this side of center line. And 125 mm on this side of center line. And again in this side also, we go downward, this side upward, and then again we have diameter from here to here. We have diameter of 148 mm due to taper. This is 140 mm and leaving a gap of 80 mm. Then this diameter is 148. And then we have to join these 2 points with inclined line. We are provided with the fillet at this corner. Same way we have provided with fillet at this corner also. Provided with point at here 148 mm from here to here, and this is at a distance of 140. So we have to join these 2 points, and after this we are given with circular break 140 mm straight up to 20 mm length as we have taken on this side. Okay, then we have to provide, we have to join this with circular break section. On this side also we have to join this with circular break. Then we have to join this. This represents the inside diameter. And now we have only this portion is remaining except to draw nut and bolt. We have this diameter, distance 30 mm from here to here. This distance is 30 mm, and we are given with division of this 30 mm on downside. This distance is 12 mm, middle part is 6 mm, and then this is 12 mm again on this side. So this distance at a diameter of 180 mm, 90 mm on this side and 90 mm on this side of center line. This distance is 12 mm, this distance is 12 mm, then 6 mm distance, and then with this 6 mm distance we have to move downward. This is 6 mm distance, and after this 6 mm distance, this diameter is 148 mm. From here, this center line, half of 148, 70 mm on this side and 70 mm on this side. We have to join this 6 mm straight vertical up to here. After this 140 mm, and after this we are going with this distance from here to here. This distance is 20 mm. From here to here, this distance is 20 mm. From here, at a distance of 20 mm. From this side, at a distance of 20 mm. Okay. After this, from here to here, this distance is 20 mm. From here, 6 mm gap is again on other side. And here gasket starts, and after this 6 mm on also this side, and then 8 mm in downward side, and then again 6 mm on this side. Then we have to go down up to inside diameter. After this 6 mm on this side, we have gasket. We have gasket. If now to represent this gasket, if the thickness of section to which we are providing cutting or providing sectioning, if thickness is minimum, then we have to make it solid. We'll make it dark. No need to draw in this case the hatching at 45-degree lines. We will make it dark if the thickness of section is minimum. This is our gasket, and again on this in this side we have to represent this with the help of hidden lines. Which side part is visible, we will draw that part dark, otherwise we will make that part from here to here. This is a single section up to this gasket on down side. In same way on this side we will make it, we have to draw this dark up to this center line. This portion is visible after hatching. If we are drawing sectional view, after this, then we have to draw this with the help of hidden lines. At here, this 6 mm on this side and 8 mm of this length. Then again we have to draw this with the help of hidden lines, because this portion is not visible. And then 2 lines are for this gasket thickness up to here hidden. And now we are also able to see this line of 6 mm from here to here firm. These are visible lines. This 6 mm line from here to here, these lines are visible, these 2 lines, because when the flange join These two lines are visible. And now we have done this part, this section, and this line is visible from here to here throughout up to here, this line, because this part is of flange disc, which this part is visible from outside this part is visible up to here, and this flange is visible up to this center line as a straight line. Flange is visible like this. You can also take the help of this isometric view. In this isometric view, you can also see this flange. If you are watching from here, then you can see this flange from here to here straight, this part straight, this part straight. That's why we have drawn this line. This is visible, this section is visible, and in this this part, this section is visible, this section is visible, this part is hidden up to here, which is this part. If you are able to draw this diagram with the help of a pencil, or you can say drafter and rubber on your drawing sheet, then this line comes in a line with this part. Okay, from here to here this is hidden. Then if you are drawing properly, then some lines come in a line. Okay, we have made just rough sketch, and now we are going to hatch. Okay, this is the inside diagram of this part. This is the inside diameter of this pipe, and now we will draw hidden line for inside diameter on this lower side. Because this is not visible from outside, that's why we had drawn this part here with the hidden lines. And now we'll make short break line at here and at here. And now we have to hatch this part. Before hatching, we have to also draw hexagonal nut and bolt arrangement at here and here. We have to draw these two through holes, and through diameter of these two holes is 40 mm. In our isometric view, I think this is given, isometric view, 2 holes, comma, dia 40, or you can say 2 holes 540 mm. So we have to make holes of diameter more than the diameter of bolt. So half of 40 mm, 20 mm on this side and 20 mm on this side. Okay, and 20 mm on this side of flange and 20 mm on this side. Same way. And through this 40 mm diameter, we have to insert a bolt of M30. Through these 2 holes, we have to insert 2 number of bolt of M30. M30 means metric thread of 30 mm nominal diameter. So we have to insert a bolt of M30. Now you know how to draw the head of bolt, as we have discussed in last classes. The thickness of bolt head is 0.8 mm. Now you know what is radius of chamfer arc, what is angle of chamfer, and you have to draw bolt on this end. This is our hexagonal bolt and nut on one side. In same way we have to draw the arrangement hexagonal bolt on other end of this joint. We have to draw the front view of this hexagonal bolt on this side of joint. Okay, this is our one hexagonal bolt and this is a hexagonal bolt second on other end. And now we are going to hatch this part. We are not going to hatch our nut, bolt, rivet, keys, cotter, because hatching or sectioning is done to represent the internal details of the object, and there is no internal detail in case of nut and bolt. And we have to hatch on opposite side to this spigot end. This is our socket end. As on this side, same as on this side also, we have cavity of this side, and in this cavity we will get fit our, as our washer, like our washer, we have a gasket of this size and which get fit easily on this face, and then we will push our socket end, then we will push our spigot end in this socket part also. This is our spigot end of these dimensions. Now we have to hatch. You can differentiate two components from this sectioning pattern. We have sectioning pattern on this side up to here, and on opposite side on this part also. That's why you can differentiate which part is spigot end and which. And now we are hatching this spigot end in opposite to socket end to represent different component. Okay, now this is our sectional front, half sectional front view. Okay, now we are going to draw our side view, or you can say end elevation. If we are going to draw our side view, then as in this diagram, it is written at here XX, means this is This side view is sectional, sorry, this is sectional side view. Okay, and this section is at this line. This is our x-axis. If I am going to cut this joint about this x-axis cutting plane line with the help of knife or cutter, then whatever visible, this is that section, and at where material is removed, where there is material only, material can be removed from that place. From where material is removed, we have hashed at that section in our side view, and remaining section we are going to draw blank, and hidden line are not shown in this sectional view, in this sectional side view. Okay, and now we have to draw the cutting plane line like this, x-axis through this 70, and this is mid part is, this mid part is 30. So through this half of mid part 15 mm we have to draw a cutting plane line. Cutting plane line is thick at the ends. Through the middle of this part. This is our cutting plane line. Cutting plane line is thick at the ends. And then we will provide arrowhead at here, x. This is again x. If I am going to cut this section about this cutting plane line x-axis, then whatever visible that we have to draw in our side view, which is visible part, and from where material is removed, then we are going to hatch only that section in our side view. This is hydraulic joint which is oval in shape, so this oval shape is visible in our side view. In our side view, we have taken a horizontal center line, and then vertical center line we have to take. Okay, now we will project this center line from our front view. We will project this line from our front view. And in same way, okay, we have projected these two lines. And now if I am going to cut this section about this line, then which is part is visible? This inside diameter is visible, okay, and inside diameter is visible, and diameter from here to here 180 mm, this distance is visible, and diameter from here to here 140 mm diameter, this diameter is visible. So we have to draw diameter of 50 mm radius or 100 mm diameter. This diameter is visible, this radius, and then from here to here 140 mm diameter, this is visible, and now diameter from here to here, this diameter is 180 mm diameter. In our isometric view, this diameter is given 90 mm with radius 90 mm. Then we have to draw diameter of 190 mm, circle of 190 mm diameter is visible, And now in this hour we have drawn these 3 circles, and after these 3 circles then we have radius of 50 mm at this corner. So we have to draw a half circle of radius 50 mm by taking this as center. In same way, taking this as center and by opening radius of 50 mm, we have drawn this section, and after this we have to join this with tangent to this circle. In same way, we have to join this tangent to this, again this section. Okay, this section is tangent to this. Now we have to draw at here. If I am cutting this section, then which part is visible? I can see diameter, nominal diameter of this bolt, which is 38, and after this we have diameter of this 48 mm in flange, diameter of 48 mm in flange, and diameter of bolt is 38 mm. These 2 circles are visible at here. We have to draw now a circle at here of diameter 38 mm. After this, a circle of diameter 48 mm, sorry 40 mm, 48 mm in diameter in flange. At here also we have to draw 2 circles of 38 mm diameter and 40 mm diameter, these 2 circles, and we are going to hatch at here because we have only material at this part of bolt and only in this section. We have material only in these two portions at here and here. That's why we had hatched bolt in this case to differentiate it from blank material, or hatching is done. This is bolt from where material of bolt. This is our section about XX. Okay, this is our section about XX, or we can say section at XX in our drawing case. It is written like it. And we have to hatch this section because in this part only there is material, so we have to hatch this section. We have to hatch this section. Now this is our side view. Now dimensioning is remaining. You have to provide dimensioning and with the help of proper arrowhead, and dimensioning should not be repeated. Like if you are writing this is diameter on this side, no need to write down this diameter on this side or at here. You have to only provide the inside diameter of pipe at once, either at here or here. Okay. Now this is our half sectional front view, and this is our full sectional side view, or you can say end elevation. Now if you are going to, I have drawn just roughly on our drawing on this board, and if you are going to draw this diagram on your drawing sheet, then you have to take proper dimensions. Now for example, this diameter from here to here, this is 250, and at here this radius is 50, and at here this is 50 mm. Then this becomes from here to here, this becomes 350. Okay, now you have to use proper scale in this diagram so that it get a fit on your drawing sheet. You have to select scale in such a way. Either you have to reduce 1:2, 1:3, it's upon you. Okay, it should not be too small on drawing sheet or too large on your drawing sheet. Okay.